This experiment is absolutely wild and may confirm that we're living in a simulation. It was performed by Thomas Young and it's called the double slit experiment. So basically, if you fire particles at a screen through a split, it will make this clumping pattern, okay? What if you add a second slit? You fire the particles, it makes two clumping patterns. Everybody with me? So if you perform this with a wave, this is what you would expect to see. The density would be in the middle and it would disperse outwards, but it would look similar to the clumping pattern with the most density being in the middle. So now let's do it with the two slits. When you do two slits, as the waves pass, they create their own waves, and the waves interfere with each other at different points. This is called an interference pattern, okay? Particles clump together, waves make an interference pattern. So now let's do it with electrons. As you fire it through, you'll see a similar clumping pattern. So as scientists performed it with two slits, they expected to see two clumping patterns, but they didn't. What they saw was this, the interference pattern. For years, the scientists thought, well, maybe these electrons would collide with each other and that's what causes this interference pattern. So in the 60s, they modified the experiment where they would only shoot one electron at a time and it still made the interference pattern. So they wanted to see what was causing this, and so they made an observer. They wanted to record what was happening, and here's what's crazy. With the observer there, the electrons would make two clumping patterns. They would behave the way that they were supposed to. Without the observer, the interference pattern.
But that's a different result to what we had earlier. So here's the last bit of sneakiness that we can play with atoms. Surely now, we're going to get to grips with it. Leave the detector there, but just very quietly go and unplug it. Don't let the atoms know that you're not spying on them. Run the experiment again.
They run it again with the observer unplugged, and it's the same interference pattern. Depending on whether the particles were being observed or not, impacted the way that they would act. Like, how would a particle be aware of this? So the experiment was updated to the delayed choice experiment. They would fire a photon, there would be no observer until the photon goes through the slits, then the observer would turn on. And here's where it gets absolutely insane. Once the observer was turned on, the photon would act like it had been observed the entire time. It would go back to doing a clumping pattern, switching from wave to particle.
Experiment showed is that even though the electrons started as waves but behaved like particles after being observed, at the moment the decision to observe them was made, the electrons recorded themselves as having passed through the slits as particles. The electrons changed their state by going back in time.
Do you understand what that is saying? They changed their state by going back in time. The scientific definition of that, by the way, is called retrocausality. So if photons from a star came to Earth, let's say that star is 100 million years away, those photons went through a double slit, they would make the wave interference pattern, unless they were being observed. If it was observed, it would make the clumping pattern. Even though for 100 million years it existed as a wave pattern, once you observed it, it through retrocausality goes 100 million years in the past and acts like a particle. This is similar to how rendering works in a video game. A video game engine only renders what you perceive. It's not going to render all of the detail inside of this building until you are there inside the building. It is constantly rendering things as your perception changes. The reason why it does this is so it can save on compute power, but you have the illusion of a complete and total map. The double slit experiment suggests that the same thing may be happening with us. Things only get rendered if you're observing them. So everybody's heard the saying, if a tree falls in the woods but no one's around to hear it, did it make a sound? Well, according to the double slit experiment, if a tree falls in the woods and no one's there to observe it, does it even exist? Did it even do anything? Pretty trippy, right?